Hello everyone, I am Sai Venkatakrishnan, a PhD scholar from the Department of Computer Science and Engineering at IIT Madras. So this is week 5 live session for the NPTEL course Introduction to Haskell Programming. The agenda of this session is we would be discussing the previous week's assignment questions, and if you have any queries in the lecture or any doubts, you can unmute yourself and ask or post a question in the chat box. Okay. So um, let's start the session. So last week's assignment was not the normal assignments that you expect in NPTEL courses, which is these MCQ type or fill in the blank questions. Instead, it was a programming assignment, right? So I guess it would have been interesting to you guys. So let's discuss the programming assignment questions, the week 4 assignment questions. Okay. So let's start with the first one. The first question is they want to define a function f1 which takes a list L which consists of non-negative numbers as input. Okay, so it consists of non-negative numbers as input, that's the input, and replaces each n in the list L by 3 into n if n is power of 3 and by 0 if it is not a power of 3. And they have given a set of examples which sort of acts as a test case to your program. So for example, if we take an empty list, the output should be an empty list. That's the first one, first test case. The second is if it's not divisible by, if it's not a power of 3, then it should be replaced by 0, else it should be multiplied by 3. So 3 power 0 is 1, so 1 is a power of 3, so it is multiplied by 3, so our output is a list containing just the number 3. And the third one, if you notice, in the list 1 comma 2 comma 3, 1 and 3 are powers of 3, so those are replaced by 3 into 1 and 3 into 3, that is 3 and 9, and the remaining numbers are replaced by 0. And the final test case is you have 0, 2, 4, 6, out of which none of them are powers of 3, so all these numbers are replaced by 0, right? So this is what your program is expected to do. So were you all able to solve the first question, finding the power of 3? Okay, that's good. So what logic did you use, Tyagarajan, to find whether it's a power of 3 or not? Good, Mohammed. So what logic did you use? So the key part in this question is this sort of, you should use a map function or something, a recursive function, because it traverses the list. And the key part is there should be a if-else condition, where the if condition should check whether n is a power of 3, else it replaces by 0, or otherwise 3 into n. So this is your key condition, the key logic is part of your program. So this condition is sort of like the key one to implement. So how did you guys implement this condition, whether n is a power of 3? Okay, repetitively divisible by 3. Okay, so how did you implement it, whether it's repetitively divisible by 3? So did you write a function like let divisible by 3 n, and if n is 1, then return 1 or something like that. Is it?
Uh, Sir, am I audible?
Yeah, you're audible.
Yeah, so I essentially check the other way around. I mean, if I check that if the number mod 3 is
Okay.
not equal to 0,
Okay. N mod 3 is not equal to 0.
uh, then of course it is not a power of 3, or otherwise I divide the number by 3 and pass it to the function again.
Okay. So basically, you implemented something like um, div 3, which takes repetitive division of 3, which takes an int and
And
returns
returns a
it.
bool.
Okay,
Or
returns a bool. Okay, returns a bool. Okay, and now it the pattern matches. If it's a
of course, if it's less than 1, then
okay, you're
returns
not doing
false.
any pattern matches. You're okay. So this is n is less than 1. It is false. If n is greater than 1,
And
n equal to 1, right?
or uh, if n mod 3 is not equal to 0.
N mod 3 is not equal to is this, right, in Haskell,
Yes,
right? Not equal to 0, then you again call
yes. False. No, I return false.
right, okay, it's not divisible by 3, right? Otherwise n mod
Otherwise,
would be equal to 0,
well, you can just write otherwise. There is
right,
no condition.
right. So this should be two. Otherwise
Otherwise, you just pass
n
n div 3.
n div 3, right, right. Nice, okay. So by this you find out whether it's repeatedly divisible by 3, and now you will insert this function within say f1,
The f1, yes.
right? So in f1 you will insert it, which takes a list of integers and returns back a list of integers. It's basically, so an empty list returns an empty list. That is the first condition. That's the trivial one. Now say if it has x's, then what do you do if rep div 3 of x, right,
X, yes.
is equal to true, then
You multiply x
right,
by 3.
right, 3 into x colon, the remaining list should be again passed to f1 of x's, right?
Yes, yes.
Else it is 0 colon f1 of x. Okay,
Yeah.
right, neat. So has everyone solved the first question? Did you all use this kind of same logic to solve it? Okay, right. So basically you're finding whether it's repeatedly divisible by 3, and this part of the function is your changing the head of the list, but the remainder part of the list is yet to be changed. So you recursively invoke f1 again and again on the remaining part of the list, and finally all the list, the tail of the list would be sort of transformed, on top of which you will insert whether it's 3 into n or else 0, right? Okay. So this is what I had implemented for this question. So I basically didn't use the repeated value of 3, so I didn't want to write another recursive function. So what I did is I just used the map function. So basically the goal of the question is, if you have a list, it transforms the elements of the list, it maps it into some other element, right? So basically, say if you are passing the map function, so map list is one argument, and the function is, if and the function logic should be, if it's a power of 3 into n, otherwise 0. So this is the logic, right? So basically I wanted to make use of the map function. So what I did is, so even in the previous case you could have sort of written a map function that's pretty same only, right? So in my case what I did is, to see whether it's a power of 3, I made use of the log function. So basically, like, log is calculated to the base 10, but say like it can be calculated to any base, right? So basically, like, for example, if I find out like log of 4 divided by log of 2, so it's nothing but like log of 4 to the base 2, and the answer would be 2. Similarly, if it's say like log of 9 to the base 3, it will be 2, because 3 square equal to 9. So basically, if I want to find out which power it is, right, like if it's power of 3 or something like that, log of n to the base 3 should be sort of like a whole number, right? Then I'm sure it's power of 3. If it's like 3.3 or something, then I'm sure it's not a power of 3. So this is the logic I used to find whether it's a power of 3 or not. So what I did is I find out log base to the power of log base 3, and this is the list element which is being passed. So basically power of 3 accepts one element, and I'm passing this to the map function. So the map function basically recursively iterates to the list. So this map function does exactly this part over here. So this part your map function does. This is what your map function is, right? So this is your map function. I just use the map function directly, and to it, this part of the logic, I had passed it as one argument, and the list L1, right? Now every element of the list would be passed to this function, which is basically this logic over here, right? You are checking with each element whether it's a power of 3 or not. The same thing, it checks over here x, right? And it checks whether it finds out the log of x to the base 3 and stores that answer in A. And now what I do is, so basically I should find out whether that A log of that number to the base 3, is it a whole number or it contains some fraction part in it. So basically what I do is I take ceiling of that number and floor of that number. So ceiling is nothing but it rounds up, that's what ceiling does, and floor is it rounds down, right? So usually, like round function, like if it's like 6.5, if you want to round this number, it will be 7. Say 6.4, it will be 6, right? That's what like usually you do in a rounding function. But ceiling is sort of like, if it's 6.5 or So ceil of 6.1 will be 7. Ceil of 6 would be 6 only. Ceil of 6.6 would be 7. So ceil of 6 point anything is actually 7. And similarly, floor just does the opposite. So floor of 6 point x, right, anything is actually 6 only. So it basically gets the nearest, the closest whole number which is smaller than the one which is passed to it as parameter, that's floor. Whereas ceiling gets the closest whole number which is larger than the one which is passed as its argument. This is what ceiling and floor does. So what I do is, if it's like log of x to the base 3, if it's a whole number 3, right, then the ceiling of this number and the floor of this number would be same 3 only. So 3 minus 3 would be 0. So I check whether ceiling minus floor of that number is 0 or not. If it's a 0, then then that's a power of 3. So I just so here actually it should be a into n, I guess. Sorry, 3 into x, right? Over here. 3 into x should be the answer, because I'm basically like increasing the sorry, multiplying if it's a power of 3, multiplying into 3, right? So basically this should not be just returning a, but it should be like 3 into x. That's small mistake. Right. Okay. So this power of 3 function does. So basically I used a log function, and next the ceiling of a minus floor of a, I just find out whether it's a whole number or not, based on whether it's having a fractional part or not. So if it's having a fractional part, the difference between the ceiling and the floor would be different, because ceiling of any part of the fraction will just round up, and floor of that number would round down. So the answer would be 1 in that case. So this logic also, did you understand how I used the log function? Okay, so right. So this basically in Haskell you have like two types of numeric, all these number representations, right? So one is, if I'm sure, one is known as like this integral class. The type class is called as integral, and the other is called as floating type class. So basically, like some functions, for example, this log base and etc., they sort of they sort of, what they do is they work on the floating class. So floating class involves this log base, all these type of kind of scientific calculations. They all work on numbers which has to be of the type which comes under this floating class. Your normal types such as int, integers, like int, those things, they come under this class called the type class. So it's basically sort of the people don't want you to there are sort of, there is possibility of something called like arithmetic errors and all those things, right? So basically um, if you do if you do some sort of division or something, it becomes that recurring fraction. It will keep on repeating, it won't end, right? Those type of divisions and all those stuff, right? So to clearly distinguish those type of scientific divisions from the normal division that people use in day-to-day life, so they sort of have a different type class for which they have defined these log functions and ceiling and all those stuff. in C programming, all these log and ceiling, everything will just like work fine if you pass an int. But here, if I just pass x to log base, right, it will throw a type error stating that it was expecting something of a floating type class, whereas here it got something of an integral type class. So this from integral is basically I'm explicitly changing the type of that number, like yes, exactly. So I'm basically changing the type of that number to a float. And this float here is actually of comes under the integral type class. Not integral, sorry, the floating type class. So this sort of like even so I was slightly confused because this numeric and this floating and integral sort of um, is sort of it usually like pops into the picture when you do these divisions and these advanced mathematical functions like log and all those things. Then it comes into the picture. The whole idea of why they split these two classes is you usually have these irrational numbers and rational numbers and all those stuff, right? And Haskell, as you know, is like a strongly statically typed system. The strong type system it has. So it sort of like wants to weed out as much as errors as possible at static time itself. So it tries to make your code safe as much as possible by differentiating the operations um, which are allowed on a number. So if you are using normal int and those things, you cannot usually call these log functions. For that, you should be in a different type class. So basically, it expects the programmer to properly know what they are uh, doing and by adding these stuffs and all those things. And also the way they represent these floating numbers, they handle these numbers might slightly vary under the hoods by the compiler. What the Haskell compiler does on these integral or floating point numbers, it might slightly vary. Um, one example that I can think of is maybe in the precision that we require, right? Like the number of decimal points and how it should be rounded off, like where it should stop and all those stuff. For uh, for example, in Haskell, you have the mod operator which takes the reminder, but there are there is another operator called rem, so it's actually the reminder operator. There is this div, there is a slash, right? So so each thing is actually they are sort of like slightly different. That if you go through the Haskell manual, they explain in detail how they are different and to what type class they were initially introduced. So mod and I guess slash were sort of introduced for just normal division, something like that. Whereas rem and div, like they sort of expect a different type. So that's sort of like a slightly confusing aspect, and the key reason is Haskell is a strongly typed system, and they want to ensure the code is as safe as possible at the time when they are developed itself, and they don't want programmers to sort of like make these silly mistakes or the confusions, especially when they are dealing with these scientific calculations. Um, for example, these scientific calculations will come into picture when you like. Let me give you an example. There is this NASA. Um, I'm not uh, sure NASA or this Aryan aircraft by French company. So I'm not sure of the exact name, Ariane or NASA rover. I'm not sure. So what happened is it failed the rover or that the rocket or the shuttle, right? It failed and it wasn't able to communicate back to the Earth, and the mission was a failure. And the reason being, what they did is instead of um, what happened is the it was sort of like a joint collaboration between the European Space Agency and the French Space, the NASA Space Agency. The Europe guys were using something, were calculating the weight and all those stuff in kilograms, whereas the NASA guys were calculating in pounds. And what happened is when they passed on their code to the NASA guys, they thought that all those values were in pounds and they did the calculations according to that. And finally, like sort of when they had to get that trust and all those that logic to fire up the um, rocket and all those stuff, right? The rocket failed. So that's sort of like calculation errors, right? Because the unit of measurement that was assumed as pounds by the NASA guys, whereas they were using a different unit of measurement. So Haskell and all these stuff, like they sort of try to weed out those type of errors. In another case, what happened is in a rover they did not. So usually every number is usually like sort of, for example, your integer would take up say like 4 bytes. Your character will take up 1 byte, like that. So basically in your system, usually so for example in my laptop we call it as like a 64-bit computer. So 64-bit is because in your computer there are like these registers and all those stuff, right? I'm not going into the details, but generally that's the maximum limit, yeah, you can operate on in an individual instruction. So any load or store that you do, or like for example the add operation, like if you are adding two numbers at the assembly level directly in your machine, right? So everything should is the upper limit, so it's like 64-bit. So this is what is known as your native length or native word size usually. So what happened is in one of the logic, they have to write code for say uh, 16-bit, assuming that it's just like a 16-bit code or something. So basically all your numbers will take up 16 bits, as in 2 bytes, right? But instead they wrote code for something else. So what happened is this sort of resulted in arithmetic errors. So why this should be an issue is, if you are say if you want to write for 32-bit code, but you had written that 32-bit code on uh, if you want to support 32-bit code but you had written a code for 16 bits, what happens is this 32 bits is like 4 bytes, right? And 4 bytes will support like 2 to the from 0 till 2 power 32 minus 1. So these many numbers it will support. It's sort of like 0 till 4 billion. So that much huge range of numbers you can support and you can like calculate on. But once you cross that 4 billion some number, it will sort of revert back to all zeros, right? It will sort of like just loop back. But now if you had written a 16 bits code or something, the range of numbers that it will support would be half of what the 32-bit numbers support. And this might raise an issue because if you are assuming you are working on a 32-bit and you happily do the calculations, at some place it will cross the range watch which is like provided by this 16 bits number and all those stuff. So then what happens is it will be an incorrect calculation and it will lead to sort of like erroneous behavior, and you won't have control over your output. So it will you cannot reason out why it went wrong and what would be the wrong answer. It will just give out garbage values, that's it. So to avoid all these things and all these confusions, Haskell sort of wants to be strict and also uh, sort of like certain in what it wants to achieve, what the programmer wants to achieve with these scientific calculations and all those stuff. So with respect to that only, they have this two different type classes and all those stuff to make it more secure. And people who are working in these critical software industries, right? These, for example, the space industry and all those stuff, where you cannot easily change your code or something, right? Once you place your code in part of your the rocket chip or something, it you cannot sort of update your code if it's having any mistake or something. It's like a one way upgrade. You cannot easily upgrade, and also the loss which is expected if your code goes in the wrong way, right? The loss is like billions of dollars and you don't want to lose it. So in those cases all, they really appreciate this type of static correctness that these type of languages like Haskell and OCaml provides. So this sort of makes sure that their code is correct in the first place, and they don't have to worry about these trivial um, issues related to mismatch of arithmetical types and all those stuff. Now they can just focus on what their overall logic is and all those stuff. So, is that clear, Sagar? Like why we did the typecasting? So, I just wanted to give a overview of like why these are important. No, there is no space between from and integral. It's a single word. It's a function name. From integral is a function provided by the Haskell library. Okay, right. So, in that case, let's move on to the second question. For a list L, define S of I. Okay, so for a list L, we have to define S of I to be the set of all indices I of I. Okay, and such that if, okay, so this notation, two exclamations mark, is this indexing operator. So in C programming, if you are having an array and say if you are writing ARR of 1, it's basically the first element, sorry, the second element, like starting from 0, 0 and 1. So that one element in that array, that is what this is referring to. So in Haskell, it's pretty much the same. So these are like two similar notations. Okay, so now they want to find out the set of all indices where I, okay, so that index element at that index should be greater than the element in the adjacent index. If that is so, then I should retain that I as part of S of I, else I can just remove that I. So they have given an example. So here you have a, so these are trivial examples, the first two test cases. In the fourth test case, it's sort of everything is increasing order, so it's an empty list. In the third test case, there is 3, 2 and 2, 1. So 3 is greater than 2, so this is picked, and 2 is greater than 1, this is picked. So the index is 0, 1, 2, 3. So you have 2 and 3 as the set of indices which satisfies this condition. So this is what your program should do. So how many of you completed this question? Are you able to solve this? Okay, good. So can any one of you share your solution, like how you went about solving this? Okay. Used list comprehensions. Interesting. So, is it possible for you to share your code snippet, Tyagarajan?
Hello.
Yeah.
Yeah, so I essentially, I mean, I defined a list uh, using the list comprehension syntax where it is the set of all indices I, where I ranges from 0 to uh, length of L minus 2,
Okay.
and uh, L of, and checked L of I greater than L of I plus. So it was kind of a short.
Right. Right. And your element would be, so this is yeah, I don't
I,
remember the syntax for the list comprehension. So this here should be I, right?
yes.
Right. So I,
And then the vertical bar,
exactly. So I, this I equal to, right?
no, it's I left arrow.
Which is symbol? I no.
uh, Less than dash. So like we write for a
Oh, okay,
right
okay.
arrow for the function. No,
Function.
it's the other way. Uh,
Oh, right. Okay.
yes.
Right. And the other choice is L and
No, it's just L of I greater than the condition, whatever the condition.
right. Right. This is a cool. So basically, okay. Good. So you're generating a new list and 0 comma length of L minus 2. That's your length of L minus 2, because length of L is like 1 greater than the actual index. And minus 2 is you're going up till the last element, second last element.
Second last, yes.
Right. Okay. Nice. So others, did you all follow the same logic of this comprehension, or did you use something else? Right. Good, Tyagarajan. I like this approach. So let me share what I did. So I didn't use list comprehension. So I just did the normal way of defining a function f2 and then auxiliary function f2 underscore aux. So basically, why I did this is I should find out the index, right, which is associated with each element. So when I do a recursive iteration of the list, right? So basically, in a recursive iteration, I'll be doing x of xs. I'll be doing something on x, and then I'll be calling. I do some calculation, some logic, I'll be including, and then I'll be again calling, say f2 with excess, right? Remaining part of the list should be processed. But here, once I call f2 again, if I pass this excess, right? Now the new excess, the tail of the list comes in, and the tail of the list comes in, but I'm not sure now what my index should be. So if you are just operating on the tail of the list each time, the index should be sort of like decreasing by one always, right? So you should sort of keep the context of the index that you are working on from the starting itself, irrespective of the recursive call. So basically, um, you should be passing your index, sort of like you should be having your index variable stored in a global state or something, outside your function. It should not be zeroed out on every recursive call of the function. So for example, if I'm having a list like 1, 2, 3, 4, in the first invocation of f2 I'll be working on this head where the index is 0, and when the tail is passed I will be working on this head. But here I should not tell this is at, since it's at the head of this part of the list, it's at index 0, but the index should be with respect to its original list, so it should be 1, and it should be 2, 3. So this I should sort of remember. So for this, my recursive function should take not only the list as the parameter, but also the index, what the element which it is working on with respect to its original list. So this is an additional parameter that my function is taking, f2. But in the question they have specifically asked, f2 is a function which takes an list of integers and returns a list of integer. So there is no way for me to include an optional argument which denotes this current index element that we are working on, right? So for that only I am using an auxiliary function where the so where I am changing the function definition. If you notice over here, I am taking now a int, which is the index, current index, and the list of integers, that excess part, tail of that list, and this the output list that I am returning back. And my f2 basically invokes f2 auxiliary function with the same list L1, but my index I am initiating it to 0, initializing it to 0 and invoking f2 underscore auxiliary. And my logic is I'm doing a pattern match where so same way as this logic is over here, right? Length of L minus 2. So in the same way, I don't pattern match on an empty list because it tells it's a non-empty list L of integers. But there is a condition where okay, so here this part over here, so this should be like sort of not commented out, because so it should sort of satisfy in this with one element or more than one element also. So this should be sort of like the same empty list actually, right? So this is the first condition, which is if it's having just a integer x in the list, it sort of returns back the empty list. That's my first pattern match. And the second pattern match is it's at least two elements. So for that, what I'm having is one with just two elements and the other is more than two elements. Okay, so here I'm just seeing if x is greater than y, I return back n, which is the current index I'm operating on, as a list. I'm just appending it into an empty list. So basically it means I'm returning back this list. And the recursive condition is if it's more than two numbers, I'm basically returning back n, that's the current index if x is greater than y, and the remaining part of the list, which is this part, right, y colon xs, I am again invoking f2 of underscore aux, the auxiliary function, the recursive function. I am again invoking, but here I am increasing the current element index that I am working on. So initially it was x I was working on. If that is greater than y, I am including the index where x is belonging, which is I, that is n. Whereas now in the next iteration I should be seeing whether y is greater than the adjacent element. So for that I am increasing n plus 1 and I am invoking f2 underscore auxiliary again. But say if x is less than y or equal to y, then I am not adding this index n to the front of my list. I am just invoking the recursive function again, the same part, and that's it. I'm not adding anything. So this is like a clean way of doing it using list comprehensions. That's a neat way. This is for those like who wanted the logic to be like sort of um, laid out and be clearly explained, right? So any doubts in this question, why I used an auxiliary function and what's the use of how I did the pattern matching and all this stuff? Okay, that's fine. Okay, so in that case, let's move on to the third question. Okay, define a function f3 which takes a list of integers and returns a list of integers and removes the adjacent duplicates. That is, if the same element occurs n times contiguously, we retain only one copy. So basically it takes an element and all the adjacent duplicates it is removing and just retains just one, and this is removed and this 2 is retained, all these are removed, this 3 is retained. So but here if there is it's not like if they are not adjacent duplicates but they are having another number in between those duplicates, then those duplicates are retained as such. For example, 1 comma 2 comma 1, even though 1 and 1 are duplicates, there is a 2 in between, so we are retaining as it is. But whereas over here 1 1 and 2 2, we are retaining just 1 comma 2, just one copy. Okay, so how many of you did this question, and if yes, how did you implement the logic? So anyone, can you unmute yourself, or can you explain in the chat box if you have if you have solved this question? How did you solve this question? Sagar, do you want to share your solution if you have solved it? Are you sharing it, Sagar, or okay? Right. So Sagar has shared his solution. It, let me just write it down. So f3, it takes an integer and returns back an integer, list of integers. Sorry, it's an empty list, just an empty list. The other case is if it's just a single element x, then just returning a single element. Okay, these are trivial conditions. And the next condition is if it's x, y, x's, then x equal to y equal to f3 of y colon x's. Otherwise, x of f3 of y colon x's. Right. Fair enough. Okay. Good, Tyagarajan. Good, Saga. Yeah, it's a clean solution, Saga. Good. So what you are basically doing is your so if it's just a empty list or a single element list, the trivial condition which just returns back whatever it is because there won't be any duplicates. But now if it's more than two or more elements, then you check the first two elements, that is x and y. If it's the same, you don't include the first duplicate, you just pass on the tail of the list, you invoke f3 again. And now if y becomes the new head and the next element of x is the new y, and now if it's not the duplicate, then this y, the second duplicate would be included, which is part of your otherwise clause. So by that, what you're doing is you're making sure that you are including just the last duplicate that you are finding. So if it's like 1 comma 1 comma 1 2 comma 3, you are removing these ones and including this one and 2 and 3, right? Nice. So this is a neat solution. I did the same thing, but instead my solution works in the way that I'm including, say if it's 1 1 2 3, I'm including this one and I'm not including these ones. So this is my solution. So it's sort of the same one, but what I'm doing is I'm making use of this function drop while, and the condition being passed to it is this. So what I'm doing is, say if it's a list of integers where 1 comma 1 2 3 comma 3, I am taking the head of the list, and what I'm doing is I'm including this in the resultant list. Right, I'm including this in the resultant list, but the remaining tail of the list, since I'm making use of the clause that these are all adjacent duplicates that should be removed. So the easy way for me to easily denote this is this function drop while, and drop while basically it takes a parameter, a condition, right? Condition and a list, and starting from the zeroth element of the list, the starting of the list, it checks whether the condition is false or true, and if it's a true condition, if the condition satisfies, it drops that element. Okay, so basically what I do is retain the head of the list, and in the tail of the list, all the elements, the adjacent elements, until I traverse all the elements which are till I traverse all the elements which are equal to the head of the list. In the tail of the list, I will drop all the elements, and this will happen until I reach an element which is not equal to x. So that's what basically this part of the code does. Drop while, and the condition is equal to x, and the tail of the list I'm passing. So now what happens is, in the tail of the list, I'll be checking 1 equal to 1, condition is true, I'm dropping this, and again the condition is true, I'm dropping 1. Now 2 equal to 1, it's a false, so I stop dropping it. So this drop while will exit then, and drop while will exit then. And now what happens is, basically this dropping happens, this drop while acts on this x's, and the recursive portion, right, f3, I'm not passing directly x's to the recursive portion. Instead, I'm dropping all the repetitions, all these repetitive adjacent duplicates, and the remaining part of this list only I'm passing as the tail of the list to f3 again. So if you notice over here, this is the entire part I'm passing it to f3. So the dropping of duplicates, I'm doing it in drop while, and after dropping the duplicates, I'm passing the remaining part of the list to f3, because once if I again call f3, if it's more than if it's more than one element or something, it will invoke this x, and it will it will retain the starting element 2, and on this it will see whether any element which is equivalent to 2, those are all dropped off. So this is a solution that I did. And now say if it's a one element list, what happens? One, so one colon drop while equal to one, it an empty list only, and f3 of an empty list. So this will be the same one only. So it works on an individual list also. So this is my solution. Any doubts in this? Did you understand this solution? Yeah. Yes, Sagar. Yeah, thanks, Tyagarajan, and thanks, Sagar. So this sort of, yeah, it's good to use these library functions because it makes, that's exactly why they were introduced in your Haskell libraries, like because their usage is sort of like more common, and it's it basically comes with practice in coding and all those stuff, right? So that's it. So for in the case of the previous example, I came up with this sort of like whole complicated solution, but Tyagarajan came with this list comprehension, which is very nice and easy to understand, right? So the same way only. So it's just a practice, and using these make the solution much cleaner. Okay, good. So if there are no queries in the third question, then let's move to the fourth question. Let's define a function f4 which takes a list of integers and returns back a list of integers, a nested list that partitions the given input list into all its operands. And the operand is a maximal non-decreasing segment of the given list. Okay. And I have given a couple of examples. If it's a 5 and 5, so if it's an empty list, it just returns an empty list. But here, if you notice, this empty list is of type nested integer, and here, if it's even a single element, it's a nested list. And if it's 1, 2, 3, 4, 5, this is a single operand, so the whole thing is part of a single element in that nested list. And if in the final test case, this is one operand, 1, 2, 3, 4, 5, 6. This 5 is separate, 4 is separate, 3 is separate, 2 is separate, 1 is separate, because they just have to denote operands. Okay. So were everyone were able to solve this question? Are you able to solve? If you are able to solve, can any one of you share your solution? Were you not able to solve this question? Was it difficult? Hello? Am I audible? Okay. Yeah, so were any one of you able to solve this fourth question, or did you face any challenges?
Uh, Hello, sir. Yeah, I
Yeah.
was able to solve, but yeah, it was a little bit uh, tedious, I would say. I mean, there were a couple of auxiliary functions that I had to define.
Okay.
Uh,
Auxiliary. Okay.
so essentially, what I did was, so I currently don't. have that code ready for me to directly paste into the chat box.
Right.
I
So
can maybe
it's fine now. You can just
dis-
explain your logic.
yeah.
Just a brief.
So uh, yeah, so the F4 function essentially, I mean, I defined a couple of more functions which essentially looked at sub lists. I mean, it kind of, so given a list of numbers,
Okay.
you traverse the list until uh, the condition is met of of uprun. So until uh, the numbers are in non-decreasing order. So you traverse that list,
Okay.
and then once you uh, encounter a number which does not satisfy that condition,
Okay.
uh, I mean, you also keep track of uh, the number of elements that you are traversing. Uh,
Right.
I mean, the length of that, and then finally, once the condition is not met, you do a take and a drop where you take that many elements from the list,
Hmm.
uh, and then that kind of becomes the
So basically,
head
you're
of the
right. So you're dropping that
result, head
upfront,
of the,
dropping that upfront, and right, you're taking that
so
part
you
of
take
the
take
upfront.
take that up, yeah, yeah, that becomes the head of the result, and then the remaining part of the list kind of you recursively again
Right.
uh,
Okay. Yeah, makes sense. Okay. So you're first constructing your head, is it?
uh, sorry, I did not get what.
So okay. So you're checking your condition like you're you're computing in this left to right fashion, right?
So I can maybe just uh, I mean without including the base conditions, I can just maybe kind of uh, re- spell out, I mean, what I have done. So the F4 function takes a list, and then uh, it calls a G4 function
Okay.
which takes two arguments. Uh, the first argument is uh, a call to another function h4 which takes a list. So essentially I can maybe say f4l is equal to g4. First argument is h4 of l, and the second argument is l. So does that make sense? Yeah, yeah, exactly. And then so the h4 function essentially uh, uh, finds the length of that uprun. I mean the first part. I mean,
Okay.
so that h4 function essentially, so it takes a list. Uh, say it has at least two elements, so it has x, y, and y's, and then it compares x less than equal to y. Then it increments. So then it does one plus calls back that h4 function with the uh, tail of that list.
Okay. You basically have to
So h4 function, yeah, it takes a list, it compares the first two elements. If it satisfies the condition, then it does one plus the tail of that list, and finally it adds. So that gives us the length of the uprun, uh,
right. And now this
and then
G4 does the take.
G4 function take. Yeah, it does take of n in that list. So that becomes the head, and then do the cons operator, and then call G4 again. Now the first argument of G4 now will be a call to the H4 function with the uh, remainder of with the drop.
I didn't get the last part. Once take off N and
So
L is
yeah,
done.
take N L, then cons. Yeah, and then you do G4 of no, it's not the empty list. So take NL cons operator, then you do G4 of H4 of so in right no so
It should be under
I'm saying
H4.
that no, so the empty list that you have mentioned, I'm saying that should be uh, so in that
Okay,
place
okay.
you should write G4, yeah, G4 H4 of say LS. I will define what is LS. Yeah, and then again call LS. Yeah, where LS is drop of N of L.
Right. So basically, this G4 is your recursive function, right?
Yes.
And
Yeah.
your H4 finds the number of elements which belong to that single operand till this condition is satisfied, and
Yes.
till then it just finds the number n, and once you get that n, it is easy for you to use take and drop. So you take that many numbers,
Yes.
and since this is a nested list, this can be on the LHS of the cons operator, because that the list itself, the operand itself, is an element. So that's why it's on the
Yes.
LHS. And the RHS, you want to return back the nested list, right? So this is again you are invoking G4, but here it should find the remaining operands in the remaining part of the list after dropping that current operand.
Yes.
With
Yes.
drop off. Okay, nice. So others, did you have this similar logic? Um, okay, good logic, Tyagarajan. So mine, this is my logic. I didn't use any auxiliary functions. Instead, what I did is I didn't sort of. It's pretty much the same. This part is pretty much the same. This part over here, but I didn't use take and drop and the auxiliary functions. Instead, actually, what I did, I sort of did something similar to like folding, traversing from right to left. So the logic is same. The base condition is, if it's a single element, these are the base conditions. Else, what I do is I have to find the operand. Okay, so what I do is so basically in so the reason why Tyagarajan required multiple auxiliary functions was that he was sort of finding out the operand starting from the current element 1. So starting from 1, he was finding a 1, 2, 3, 4 up till which element is the operand. So in that case, you had to, there's no other choice other than using these auxiliary functions, because you are working on this sublists also, right, each individual operand. So it sort of complicates it. I wanted to minimize the use of auxiliary functions. So what I did is, say given this list 1 2 3 4 5 2 3 4, I didn't so what I assumed is this part is already traversed and I have found the operand. So in so basically here in Tyagarajan's case, the logic is he finds the number of elements which are present in the operand, that's the index count, right? The number of elements, and uses take and drop. But in my case, what I'm doing is I'm recursively building up the nested operand list itself, right? So basically what I'm doing is, when I come to this first element, what I do is I just recursively first I have to find the operands possible in the tail of the list. So now when it comes to the tail of the list, I just save 2 in some place, and I find the operands in this list. So basically when it reaches the base condition over here, which just say it reaches this last element 4. So I return back 4 alone. Now what I do is it returns back 4, f4 of this. When it reaches the last element, this the answer, right, up equal to f4. Now x is actually the previous element, the current head, which is like 3. And what I do is, now I see whether the head of this nested list is less than or greater than, right? If yes, what I do, I just add 3 comma 4 to this nested list. If it say like x equal to 5, that is the previous element is 5 and it's not an up run or it's a down run, so then what I do is update this thing to 5 comma 4. So that's what this does. So if the previous element is less than or equal to the head of that nested list element, then I add x to that first list, that sub list, that upper. I add it to the head, and the remaining tail I just append it. That remaining list of operands, which is the tail, I just add it. Otherwise, this x should be a part of a separate list. It's in itself a separate list, and I just add this x colon up. Though this basically like 5 comma something like that, right? And now when I return back, now it sees the previous element, and now it uh, sees whether it should be part of a separate list or it can be added to 5 itself, based on satisfying this condition, x less than or equal to head of up. So basically what I am doing is, if I am having this list 1 2 3 4 1 2 3, I don't I'm not finding the occurrence from this element point of view. What I'm doing is I'm just uh, recursively calling f4 again and again till I reach a list having just a single element, and here I return back a nested list containing 3. And now when this is returned back, the previous invocation where x equal to 2, the current list, I check whether it can be added into this list or it should be added as a separate list based on whether the upland condition is satisfied or not. If it's satisfied, I can add it as 2 comma 3. Else I should add it in a separate list like 5 comma 3, something like this. And now again I return back this result and x equal to 1. So it's sort of like I'm recursively going till the last element. Oops, sorry. I'm recursively going till the last element, and then I am traversing from right to left, doing the computation, and partly building up the upper and nested list instead of doing the computation from left to right. So is this logic clear? Okay, good. Right. Okay. So in that case, then these are all the 4 questions that was part of your programming assignment week 4. Um, so your programming thing where all the test cases like passed in your submission and you got full marks, or like did they check for even efficiency or something like that? Okay, right. So I guess then most of you would have got um, full marks in the assignment. Right. Okay, that's good. So I just have a question. So I came across this question. It's similar to the list. So say if you have a string, um, say NPTEL course intro to Haskell. Okay, I want you to write a function fi, or I will write it as my word, where if I pass the string, it should return a nested list where you tokenize your list, as in like you just remove these words separately and have it as a nested list. So basically you remove out all the white space characters. So can anyone of you try to solve this question? Okay, I've asked a doubt. I completed all the questions in week 5 except the last one to multiply matrix, but it says you cannot submit partial answers. Okay, I'm not sure about this presentation error. I guess someone has asked that slash n or something, right, in the discussion forum. I guess the TA had answered something with respect to that. So is what Sashi asking respective to that presentation error? Is that the case? What Sashi is asking? I am not gone across week 5 assignment questions. Uh, can you post that question in the forum, Sashi? I can have a look at that question, and even the TA in charge can have a look. Okay, so right. So actually, that's the end of the session. So this question is sort of so whatever I'm asking my words, it's sort of like an extra question that if you are interested. So the condition is you should write a function, my words, which sort of takes a string containing white space characters or anything, and it should return back a list of a list of strings, basically that is nested list of characters, where each string is basically that without that white space, right? You split the string based on these white spaces, and the condition is you should use only take while and drop while. Only these functions you should use. Okay, so yeah, good. Yes, you can use take while and drop while. So can you come up with a code having take while and drop while? Let's say I give you um, 5 minutes. I guess that's sort of like I'll give you a couple of minutes for you to try to think about the answer. I'll wait. So if you know the answer, you can post it in the chat box. We'll see. I'll wait for a couple of minutes. Okay. Tyagarajan has given an answer. Take while equal to of L colon 5 of L. Okay. Let's just wait for another minute. If say okay, drop while, right. The second part should be drop while. Drop while of not equal to. Right. Let's just wait for a minute. Sashi, Sagar, anyone? You have anything different from this? Right. Okay. Okay, let's see what Tyagarajan answer, how it works out. So Tyagarajan had mentioned Fi of L is take while, so where it should be not equal to, can you be specific, Tyagarajan? In ah, so take while not equal to the white space L colon Fi drop while equal to tail of L. So basically, if I have this NPTEL space intro Haskell, so what it does is it will take this list of characters until it's not equal to the white space. So all this part it will take. So this is returned back NPTEL. Okay, and now so this is the first thing, and colon the remaining is drop while equal to. Shouldn't drop while also be not equal, Tyagarajan? Because the condition is fluid drops, right? Yes. Because yeah, that's actually slightly confusing. Like drop while you assume it to be like the complement thing, right? So you, it's actually the, if it's a, the condition is the same, but it just drops or takes it. So it's like it should be not equal to. So then if it's say not equal to the white space, so the remaining list actually it should pass on to F5, and the remaining list is actually this, the white space character and then intro Haskell. Okay, and now okay, so when you mention tail of L, okay, so tail of L, in that case what do you mean? So if you mention tail of L, N is left out. So it's just ptel space intro Haskell and drop while of not equal to white space. Then these are all dropped. Is it?
Yeah, no. So actually, I think so there is a mistake there. So drop while we just pass L to drop while, and the result of drop while, uh, I mean, we take the tail of the result of drop just to leave out that extra space.
Right. Okay. So
So it's Fi of tail of drop while not equal to space and L. So the tail is out. Yeah, I think.
does this make sense? The extra parentheses. Right. So in the previous case, what would happen is if you are not removing this white space character, this one, then what happens is if you pass this whole string into Fi again recursively, take while not equal to white space, this will sort of fail. This will sort of, this take while, this part of the first part of the list constructor would fail, would not do anything. It will just return back sort of like an empty string, but it will keep on calling Fi again and again. Right. So actually, if you don't address this white space character, the extra one, this will result in a stack overflow because You will recursively be calling fi again and again with the string with the string being the sort of like the same string again and again. The string won't be decreasing in length at all. So it will just consume your stack space and it will result in an exception named stack overflow. Okay. So now if you are just dropping all the first part of all the non-white space characters and then removing the starting white space character. Okay. So if you are using tail, you are removing this. Now say if I am having like NPTEL, two spaces, three spaces, intro Haskell. Now what will you do? So I'm removing, I'm taking take while of not equal to white space. So this part is there as the first element. This is correct. Colon. I am dropping all these and this part of the string I'm taking and I'm taking the tail. So basically it is two white space characters and intro Haskell. And this part I'm passing it to F5 again. But these white space I should be removing these, right? Should not be present. And if I'm using tail, just one is gone, but remaining two are there. So
So,
here,
and would the recursive call again? So maybe I think there will be an empty string getting added to the uh, list,
uh,
but
mm,
maybe recursively it might get removed one by one.
no, it won't get removed because if you notice in your case, right, take while of this, the first part will just return back an empty string actually because the first character itself is the white space character.
Oh, but then the tail will fail. I mean, it will throw an error because that will be no
No,
drop
tail won't
file.
throw an error. Tail will just return back this string itself because it says drop while of not equal to L. So this is not equal to L, it's actually equal to this white space. So it
Yeah,
will
yeah,
just return back the same string.
the same string. Okay, yeah,
And okay, so okay, you are doing tail, right? So what you are saying is it will just remove this part. Right, so it will basically take three sort of three recursions, is it?
yeah. I think, but the only drawback is there might be empty
Right, there will
strings
be empty
getting
list.
added
So
to the
basically, it will be NPTEL.
NPTEL, then two empty strings, and then intro.
Right, right. So let us look at my solution. So in my solution, it's sort of same what Tyagarajan had mentioned, but instead of taking tail, I'm just using another drop. So I'm calling the function again f5, but instead of taking tail on this drop while of not equal to white space, I'm dropping all the initial white spaces at the starting itself instead of the tail. So does this make sense? Okay, I'll explain this again, Sachin. So say if you have the string nptel intro to Haskell, basically what I do is I am doing two operations. One I am doing this take while and the other is drop while. So the first part take while of not equal to white space character and the list I am passing. So basically what it does is it takes, so basically what I'm doing is it takes all the characters starting from the um, string. It takes all the characters until it reaches a white space character. So it takes this part of the string. So this is your first element. And now the remaining part of the string I should actually invoke the recursive function again. So the recursive function, what I do is I'm dropping the initial white space characters. So for that, and also the part of the string which I've already consumed, right, as in finished computation, these should also be removed off before I pass the remaining part of the string. So for that, I'm using two drop whiles. So this one to remove off the consumed non-white characters, non-white space, and this one to remove off any white space characters. So finally, this part of the string would be sent to f5, that the function my words or f5 again, and this will happen recursively. So I mentioned syntax is unclear. So which part of the syntax is unclear? Recursion part. Okay, so this is where recursion occurs, my words. So the recursion occurs in the RHS of this cons operator. So I'm taking out the starting non-white space characters, the head of the list that I have found out. Now in the remaining part of the list, I have to do this logic again, take while. So for that, I should drop this computed part. So I'm using this drop while, and then I'm removing the starting white space characters that are present using this logic, and this remaining string I'm again passing to my words. So this parenthesis is actually from here till here. So my words of this drop while equal to white space, and the list what I'm passing is I'm passing this one, drop while not equal to white space x. Okay, now it's clear. Okay. So in that case, then that's the end of week 5 session. So we have discussed the four programming assignment questions, and we also discussed this extra question. So you have any other queries or anything we need to discuss? Uh, which one? Why? I didn't get you, Saga. Are you asking why this condition over here? So like we are taking input as string. So for checking string limit, this one is it? Right. So basically, this and this I guess are equivalent. It's just empty list, and the string is also a list of characters. So yeah, I guess both are same only. So it works. It will type check. So I can write the same NPTEL as NPTEL. So both are same only. So it is just like a shorthand notation. Is your doubt cleared, Sagar? Okay, good. Yeah. So in that case, if there are no other queries, then we can wrap up this session. Thank you all for attending and making the session interactive. Thanks, Tyagarajan. Thanks, Sagar. Thanks, Sashi. Thanks, Mohammed. Thank you. Okay. See you all next week. Um, have a good weekend. Thank you.